Xiaomi has released its visual language models. In this video, let's look at MiMo-VL-7B-RL from Xiaomi. So what they have done is that they have created a base model, a base visual language model, which is MiMo-VL-7B, and then they created a supervised fine-tuned model, which is MiMo-VL-7B-SFT model. So this was created by a 4-stage pre-training phase, which includes projector warm-up, vision language alignment, general multimodal pre-training, and long context supervised fine-tuning. So they created this supervised fine-tuned model. Then they had a subsequent post-training phase where they introduced something called as mixed on-policy reinforcement learning, which is a novel framework that seamlessly integrates diverse reward signal spanning perception, accuracy, visual grounding precision, logical reasoning capabilities, and human or AI preferences. And this phase yields the MiMo-VL-7B-RL model. So this is the reinforcement learning model with multi-modal reasoning capabilities. So here they have compared the benchmarks and other things. What we will do is that we will try this model on a Colab notebook on some visual reasoning tasks, and then we'll come back to the architecture. Let's go to our Colab notebook. So this model requires at least 16 GB of RAM. So I'm running it on an A100 instance. This can possibly run on a L4 instance as well, right? Both L4 and A100 are paid instances in Colab. So first you need to install Qwen VL utils, and we'll be using Qwen 2.5 VL for conditional generation, the processor as well as the model. And here we are specifying our model to be Xiaomi MiMo, and here I have specified torch D type is equal to B float 16. Otherwise this would take close to 30 GB of GPU VRAM. Okay, so in this way you can actually load the model and the processor. So once you do that, you create your messages like this. Okay, so here we have an image, and the question from the user is giving this image, and the question is how many different colored beads are there. So what I'm going to do is that I'm going to give this image of an abacus, and I'm going to ask how many different colored beads are there. The answer is there are 5 different colored beads over here. So you have 5 colors over here, right? Then we apply the chat template on these messages, and then we give it to the model by, the processor processes it, and then we give it to the model and we generate our output. Okay, so if you look at the output over here, we are generating max new tokens of 128 over here, and it says that these are 5 unique colors. There are 5 different colored beads. The 5 unique colors are green, yellow, beige, red, blue. Okay, which is correct over here, right? And so then I increase the number of tokens, output tokens, and I said, can you count the number of beads for each color? So I've given 1024 tokens as the number of output tokens that needs to be generated over here for the same image. So it goes into this think phase over here in the previous case also. Then it says, so let's look at the Abacus image, identify the colors. It identifies there are 5 colored beads. Okay, then let's list each color. Let's count. Each blue row has 7 beads. Wait, no, let's count the bead. There are 5 vertical rows. It goes into a lot of that counting over here. 7 plus 4, 7 is equal to 14. And then it says 14 per this thing, right? It's not able to generate this answer within this, 1024 tokens. We'll change it to 4096 and see if we can get some better output. So let me run this. In the meanwhile, we can look at some other outputs, some other images. Okay. Then I gave it this particular challenging image of muffins and Chihuahua dogs over here. Right. This is a tough image for AI previously, but current day visual language modeling models are able to do it very well. Okay. So I gave this particular image and I said how many dogs are in this image. I increase the max new tokens is equal to 4096 for the output. And finally, it says that the number of dogs in this image is 17. It says that subtract the number of muffins. So it is able to identify that in this image, you have a mix of dogs and muffins. Okay, so here it checks and says that, how many grids are there, how many dog faces are there. Then there is muffin, right? So if you look at row 2, it says first column is dog, muffin, muffin, dog, muffin, dog. So if you look at this image in the second row, you have dog, muffin, muffin, dog, muffin, dog, right? So that's the sequence which we have over here, and here says dog, muffin, dog, muffin, dog, muffin, dog. Okay, so it tries to count like that, and it says that there are 17 dogs. When I did a manual count over here, I got the number as 18, but it's somewhere close. Okay, so this was another reasoning problem which I tried. The next reasoning problem I tried was I gave this particular medical image of a tablet which has an antibiotic, cephalexin, And then I asked a question over here, is that can I take this medicine if I'm allergic to penicillin? Let's see. First, it needs to recall that about cephalosporin and penicillin allergies. So it has done a good OCR job. It is identified that you have cephalosporin. Cephalexin is a cephalosporin. There is a cross-reactivity risk, especially the first generation cephalosporin. Cephalexin is a first generation cephalosporin. So if someone is allergic to penicillin, they might have a risk of allergic reaction to cephalosporin. However, the risk is lower than with penicillin, but it's not universal. So it kind of, what is the final conclusion? Do not take this medicine without first talking to a healthcare provider. The risk there exists, especially with severe penicillin allergies. So, allergic patients react to cephalosporin. Penicillin allergic patients react to cephalosporin. The risk exists, especially with severe penicillin allergies. Do not take this medicine. So actually, it's given a correct answer over here. If you Google, with this particular medicine, and if you Google about cross allergies with penicillin, you will get this answer. So it has done a good job here. Okay. Then I asked another question where I gave this image of Pythagoras theorem. Right, you have this hypotenuse is equal to BC square is equal to AB square plus AC square. So I gave this particular image as input, and I said, what is this diagram about? Typo over here. Can you calculate the side of a right angle triangle if two sides are 12 centimeter and 15 centimeter? Let's see what it has done. Diagram shows a right triangle, which is the basis for Pythagoras theorem. In the triangle, it explains that. Right, BC is the hypotenuse, so you have this formula which states this thing, so it explains that image properly. And now the question is to calculate the side. If two sides are 12, 15, we need to determine which sides these are, whether they are both legs, one leg and hypotenuse. Let's consider both cases. Both 12 centimeter and 15 centimeter are legs, AB, AC. Then hypotenuse can be found using this formula, substituting the values. 144 plus 225, 369. Wait, no, 12 squared is 144, 15 squared is 225, is 369. Does some kind of mix up over here, but again gives the correct answer. It does all kinds of thinking and some kind of mistakes over here. Let's see what is the final answer. It's a Pythagorean triple. It's probably that 15. Then for calculation, we need to say it's not able to really generate a proper answer over here with 1024 tokens. It is understood that it's a image, a Pythagoras theorem image. Maybe we'll increase it and see it. Now let's go back to our first thing where we increase the number of, the tokens, basically token size we increased, and let's see where we had it over here, right? Yeah, beads for each color, 4096 tokens. Let's see what is the answer over here finally. It says 14 beads over here. There are 5 different colors. Each color has 14 beads. If you go over here, you have how many beads over here? Since it's an abacus, you have for every color you have 10 beads over here in every row. 3 plus 2 5 plus 2 7 plus 3 10. Okay, so for every color you have 20 over here, and it estimates as 14. So somewhere in this it starts process and other things have gone for a mess over here, right? You still have this particular part running, so it's actually computed the hypotenuse for this particular problem for this right side of a right angle triangle if two sides are 12 and 15. And it says that if you look at the final response, it says that mostly second situation is a probable situation, and the hypotenuse is somewhere around 19, which is actually kind of correct. Somewhere I saw this particular response, this approx 19.21, which seems to be the square root of 369. So this seems to be fine. Okay, but I had to increase the number of max new tokens for this. Let's look at the architecture of MiMo-VL-7B, the visual language model. The main components are, there is a native resolution VIT, there is a LLM backbone, okay, and then there is a MLP projector. Now let's look into what are these components. So the vision transformer or VIT encodes visual inputs such as images and videos. They have made use of Qwen 2.5 VIT. Then there is a projector that maps the visual encodings into a latent space aligned with the large language model, which is your MLP layer or MLP component. Then you have the LLM itself, which performs textual understanding and reasoning. So this is how they have created it. The MiMo-7B base from okay. Stop. Fine. Now what else is there? So here they have explained about the various training stages. So the initial training stage is a projector warmup, which takes input as image caption pairs. Then the stage 2 is visual language alignment, which takes interleaved data, image caption pairs plus interleaved data. The third stage is multi-modal pre-training. So it takes image caption pairs plus interleaved data plus pure text OCR, grounding, question answering, video, GUI, images, instruction data, reasoning data. And then you have long context supervised fine-tuning, which is stage 4, where you have all these things plus long pure text, long documents, high resolution images, extended videos, long reasoning data. They've also given the training token size over here, and if you look at stage 3, it is close to 1.4 trillion tokens, and in stage 4 you have close to 550 billion tokens. So this is actually giving you your MiMo-VL-7B-SFT model after stage 4. Okay, then you have a reinforcement learning. So in the post-training phase, they are going to do reinforcement learning with verifiable rewards. So where they want to do with on visual reasoning, text reasoning, image grounding, visual counting, and temporal video grounding data. That is what they are saying over here. They also do reinforcement learning from human feedback as well, right? And they have come up with something called as mixed on policy reinforcement learning. If you want me to cover the details of, the technical details of mixed on policy reinforcement learning and how they have done reinforcement learning, I can create another video. You can look at this paper and understand more about, what are the reinforcement learning techniques they have used over here, and, what were the data sets which they have used. So this is a short video on Xiaomi vision language model. Okay. So this is MiMo-VL-7B-RL. So you can also go and check out this model. I'll be sharing this Colab notebook in the description of the video. You can check out this Colab notebook as well. Hope the video is useful. See you in another video.